to look at frequency and histogram. So we're going to create stem and leaf plots, and we're going to create frequency tables and histograms. So we're going to be looking at data and organizing data into stem and leaf plots, histograms, and then we're going to look at, do a little bit from 10.3 also, the next lesson, which will be doing mean, median, mode, and range. And then tomorrow we'll be looking at box and whisker plots, and also looking at misleading data. So when people send you messages that are a little misleading. And I think a lot of that, we found a lot of that during the election, where there was a lot of misleading data that what happens a lot of times is polls are taken in big populated areas, unfortunately, and it leads people in the wrong direction. So we'll talk about that more tomorrow. All right, so I know you guys have done these, so this should just be a nice little review for you. So stem and leaf plots arrange data by dividing each data value into two parts. This allows you to see each data value. So whenever we have like two-digit numbers, then the tens digit will be on one side of the stem, and the ones digit will be on the leaf. Right? So sometimes if you have decimals, then the decimal will be where the cutoff is and changes it is. If it just depends on how many numbers you're dealing with. If you're dealing with two-digit numbers, then the tens digit will be on the left side, the ones digit on the right-hand side. If they're bigger than that, like if they're in the hundreds, then you would have the hundreds digit and the tens digit will be in the stem, and just the ones digit in the leaf, right? So here we've got a set of numbers. It says the numbers of defective widgets in batches of 1,000 are given below. Use the data to make a stem and leaf plot. So what's the first thing I need to do to make a stem and leaf plot? What should I do first? Okay. First thing to do then is going to be to order them from least to greatest. So always smallest to largest. So we'll do that first. Okay, so let's see, we've got 2 8s and 2 9s. And so basically when you're putting stuff on your paper, when we're working with this stuff, you should just, instead of writing the whole data set down, I would just put them down in order to begin with. But just be careful that when you're done, you make sure you go over them a second time so that you know you've got, number one, all the numbers, and number two, that they're correct. All right, so we have 2 8s and 2 9s. Let's see, there's a 12. And looks like 2 13s. 14 and a 15. And 19, 20, and 21. All right. So here we're dealing with single digits and tens digits. So on the left-hand side, I'm going to have a 0, a 1, and a 2. All right? So 0 represents all the ones digits. The 1 is represent all of the tens, from numbers from 10 to 19. And the 2 represents all the numbers from 20 to 29 then. And the thing to remember about stem and leaf plots is that when we write them down, we do not use commas. Okay? Don't use commas. So we just we have 2 8s, 2 9s. Right? So we just write 8 8 9 9. And that we realize and recognize the fact that each number represents a single, in this case, defective amount of defective widgets. All right, so then we'll do 2, 3, 3, 4, 5, and 9. All right, so once again, remember, no commas, just write the numbers. And 0 and a 1. Okay, so when doing stem and leaf plot, order from smallest to largest first. Okay, and then remember that there are no commas. All right. Sometimes people like to separate their numbers with commas, but in a proper stem and leaf plot, there are no commas. All right, back-to-back stem and leaf plot. So sometimes when we have two sets of data that we're comparing, then we're going to make a back-to-back stem and leaf plot. All right, so the first thing we're going to do is we'll take Team A, write those numbers in numerical order from smallest to largest, and then also do that with Team B. Rewrite their numbers from smallest to largest. All right, so once we get them in order from smallest to largest, in this case, they're all two-digit numbers. All right, so we have to find the smallest two-digit number first. Okay, so what's the smallest one in both sets of data? What's the smallest one? 37. Okay, so my first stem is going to be a 3. And then we have to go in order. Even if there are no numbers there, we have to go in order then. So when our largest number is 72, so we're going to need a 3, a 4, a 5, a 6, and a 7. Okay. All right, so now we need to label this a little bit. All right, so we're going to put Team A, we'll put them on the left, and Team B, we'll put them on the right. Now, the stem is always where the smallest numbers are going to go. So this represents, basically, you could say this is the 30s, the 40s, the 50s, the 60s, the 70s. But the 0, the closest number to them, goes closer to them. All right. So you have to remember that everything's going to work from the middle out. So when we're working on Team A, the smallest number is going to be next to the leaf, and then as we go to the left, it'll be the bigger number. All right. So we've got 2, 2, 5, and 9 for the 4s. All right, so 2, 2, 5, and 9. So it has to go that direction. All right, we're not going to go the other way. Always the smaller numbers are closer to the stem. So 5, 6, and 8 for the 50s, a 1 and a 5 for the 60s, and then the 2 for the 72. Right. Then we do the same thing for Team B, smallest closest to the stem, and then go from there. Once again, no commas. All right. You guys remember how to do all them? Thanks for the reminder. All right. Let's do this. All right, so make this one. Okay. All right. Histogram is a bar graph used to display the frequency of data divided into equal intervals. The bars must be equal width and should touch but not overlap. So to make a histogram, to make a histogram, first of all, we need to make a frequency table with specific intervals. So here we have a set of numbers, and we're going to make a frequency table first of all. Right. So when we make a frequency table, we have to look at the numbers that we have, and we have to pretty much, we're going to divide them into intervals where that they fit nicely for making the histogram, for the bars for our histogram. Okay. So here we have the number of students enrolled in Western civilization classes at a university are given below. Use the data to make a table within the intervals. Right? So once again, the first thing we want to do is we want to rewrite them in order from smallest to largest. So let's see what we got. 12, 14. Oops, we have a 9. Almost missed that. Let's see, 18, 19. 2 22s. 25, 28. And 31, oops, 27. See, that's why I cross them out so I don't miss any. 27, 28, and 31, 32. Okay. All right, so once we have them, all of our numbers in order, okay? So we look at the smallest and the largest number, and we want to make an interval that our histogram, we only want it to have about 5 bars, okay? 6 bars would be okay, so what we want to do is we want to divide this into intervals so that we're only going to be working with about 5 or 6 bars, right? So we'll take the 32 and subtract 9, so we're going to take the largest number, subtract the smallest number, and then we're going to divide it by 5. All right, so we can basically find how wide we want our intervals to be. So what's 32 to minus 9 is 23. If we divide 23 by 5, we get approximately 5, right? Okay, so we're taking the largest number minus the smallest one, and then we want about 5 intervals, so we'll divide that number by 5. And that tells us about how long our intervals are going to be. All right, so we're going to make a table then where we have 5 rows into our table. So we need 2 columns and 5 rows. All right. So our first one is going to be from 9 to what? And you can do this a couple different ways. It doesn't always have to be perfectly this way, or you can always start with the even numbers also. All right? But you can make it work with just starting with that smallest number. Okay? So if I go 9 to 14, oops, I want 9 to 13, not 9 to 14. 9 to 13, okay? That's an interval of 5 units, okay? 9, 10, 11, 12, 13, okay? So then we'll go from 14 to 18. (19) through 23. 24 to 28, and then 29 to 32. All right? And this will cover from our first to our last number. Okay? Now, the amount of data in each one is going to be different, okay? But these have got to be the same width. Now, you could change this. We could go from 6 to 10, 11 to 15. You know, we could do do things like that also. But you just need to make sure that these are the same width, right? And you want about 5 or 6 of them. So like I said, we could do differently if we wanted to. We could say, okay, well, since we have the number 9, we're going to do 6 to 10 would be one of our intervals. And then we could do 11 to 14, or 11 to 15, excuse me. And 16 to 20, and 21 to 25, 26 to 30, yep, and then 31 to 35, all right? So we would need if we went that route, we would need another row, okay? And it just depends on you, okay? Because they're all going to be a little bit different, all right? Nobody's going to be the same as anybody else. I mean, they will be. Some of them will be the same. But there will be, some of you will do them a little bit different than others. And is that okay? Yes, it is, okay? They don't have to be exactly the same. So now when we do a frequency table, all right, so in this column here is going to be our frequency, which means how often do numbers occur in that grouping, okay? So from 9 to 13, we have 9 and 12. So we have 2 numbers there. So our frequency will be 2. From 14 to 18, we have 2 numbers. 19 to 23, there are 3 of them. 24 to 28, there are 3 there also, and 2. Now, is this always going to happen this way? No, it's not. Sometimes you'll have a bunch more in the middle, maybe you'll have more on the outside. All right, but the big thing is setting these intervals the same, all right, the same width, and that becomes a challenge sometimes, all right? So double check your numbers, even if you gotta use your fingers like I did, okay, to make sure that they're all the same width, okay? It could be 2, it could be 4, it could be 5, it could be 8, it could be 10, all right, depending on how many numbers you've got. All right, so there's our frequency chart, and so we're going to go ahead and use that then to make our histogram. All right, so when we make a histogram, histograms look just like bar graphs. With a bar graph, most of the time there's a gap, all right, between each category. Okay. With a histogram, there's only a gap as if there's no data in that interval. Okay. So to make a histogram, we want we're going to use a quadrant graph for this. All right, so which I'm going to have to redo this. Okay, so we want our x-axis, so along here, we're going to start at 9 and go up to 32. And, oops, I'm going to go to 33, I'm going to go 1 past that. And we're going to go by 5. Oh man, it's not going to draw it the way I wanted it to, is it? Darn it. All right, well, we're going to get rid of him. He's not going to help us. Delete. Okay. There we go. All right, so we've got intervals here that we're going to start with 9 here, and then we've got 14, and then 19, 24, 29, and 34, sorry. And the thing to remember is that this bar starts at 9.0, goes to 13.9999999, okay? And 14.0 to 18.99999. So notice that these numbers here that I'm using for my interval, to start my interval, are the same first numbers I'm using here, okay? And that one should be 33. 33. Be the same length. Okay. All right, and then we've got our quantity. So we got 1, 2, 3, 4. So whatever you need to on your y-axis is the frequency then. Okay. Along the x-axis is our intervals. Along the y-axis is the frequency. So the x-axis here for this histogram is really going to be students enrolled in Western civilization classes. And then we have the frequency. Okay. So we've got 2, 2, 3, 3, and 2. So we're just going to make rectangles. All right, so we make a rectangle that's 2 units high to represent the ones from 9 to 13. Then we'll do another one from 14 to 19 because there's 2 of those. All right, and the thing is there should be no gaps here. There should be no blanks unless there is a 0 in one of your regions. All right, and then 3, and 3 again, and then 2. All right. Here's our histogram. All right, so the first thing you have to do is we have to make a frequency table. So when they give us the data, we make a frequency table, divide up the intervals evenly, right? And like I said, you could start with the lowest number, go to the highest number, all right? Or you could make them, if you want to do it more uniformly with the numbers like 6 to 10, 11 to 15, you can do that. It's basically you and how you like it, right? How you prefer it. And then with your histogram, there should be, once one rectangle ends, the next one starts, unless you have a defined gap where there's nothing in that data. So if I had no numbers from 19 to 23, then that would be blank. All right, that's the only time I would have a gap. Okay. All right, let's go on. Mean, median, mode, and range. All right, so these are measures of what's called central tendency. All right, and we're going to touch on them a little bit, and then we'll be good for today, and then we'll work on box and whisker plots tomorrow. So remember, the mean is the average of all the numbers. So we add them all up, divide by how many there are. Median is the middle number. Mode is the one that occurs the most often. There could be one mode, there could be more than one mode, or there could be none. Right? For the modes, if all the numbers are different, then there is no mode. Right? Or if they're all the same, there is no mode either. Right? And the range is the difference from the least to the greatest, smallest to largest number. All right, which with that set of data we just worked with, the range would have been 23, from 9 to 32. And remember, the range is an actual value, and it describes the spread of the data. It talks about how spread out it is. One of the things that we'll talk more about here, and then again in Algebra C, is we'll talk, when we're dealing with these, talk about how spread out data values are. And we'll talk about something called standard deviation and how that affects it. And if you go on and decide to take AP statistics, then we really talk about it a lot. All right, so let's take, we're not going to use this set of data. Let's go back here and let's use this set of data again because we just put it in numerical order. All right. Okay, so we want to find the mean, median, mode, and range of this set of data. So what do I do to get the mean? Taylor, what do we do? Okay, take the average. So we got to add them all up and divide by how many there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. So we add them up and divide by 12 to find the mean. And we're going to round to 1 decimal place. All right, and Ellie says we got 21.6 approximately. Is that, you guys agree with that? Okay. All right, how do I find the median? How do we find the median? And the median is the middle number. So how do I find that? Well, so we've got 12 of them, right? Okay. So we know that with 12, then the median is going to be between the 6th and 7th number, because there's the same number of numbers on each side of the median. So we've got 1, 2, 3, 4, 5, 6, and 7. So in this case, the median would be right between these two numbers, all right? Because then there would be 6 below it and 6 above it. Since these are the same, we're good, it's 22. Okay. If they're different, then you find the average of those two numbers. Okay. So when you have an even amount of numbers, it's always going to be in the middle, it's going to be the average of two numbers there. If you have an odd set of numbers, then it would just be the middle number. Okay. All right. Mode. Mode is the one that occurs the most often. All right, in this set of numbers, it looks like the only one that repeats itself is 22. So the mode would be 22. And the range is 32 minus 9, which is 23. The greatest number minus the smallest number. One thing I always remember is that the range is a single number. Sometimes people say, oh, it's from 150 to 163. No, it's not. It is actually that number of what I get when I subtract them. So don't forget that. All right. So a value that is different excuse me, from other values in a set is called an outlier. So in the data below, one value is much greater than other values. This causes the mean to be greater than all the other data values. In this case, either the median or mode would be better to describe the data. So when you have an outlier, if it's bigger or smaller, what it does is it pulls the mean up if it's bigger and pulls the mean down if it's smaller. And so when that happens, lots of times finding the median or the mode are a better way of talking about the middle number, okay, what the normal average score that somebody would get. And so you have to be careful of if there is an outlier, that how it's affecting your data. Right? So here we've got Rico scored these 6 scores on his history test: 74, 73, 80, 75, 67, and 55. Right? So use the mean, median, and mode of his scores to answer each question. Right? So they gave them to us. Here's the mean, here's the median, here's the mode. Right? So the question is, which value gives Rico's test average? Right? Well, what's his test average? An average is always the mean, right? Okay, so his average is 70.7. But in this case, which value best describes Rico's scores? Well, if I say his average was 70.7, then he's only got 2 scores that are below that. But most of his scores were in the mid-70s, okay, and higher. So in this case, the median would be a better way to represent Rico's scores than using the mean. So because in this case, the outlier 55, because it's much smaller, it's pulling the average down, you'd be better off of using the median to describe Rico's scores. All right, so you just need to be careful on those types of problems. All right, so is there an outlier? If there's an outlier, it affects the mean, and so you're better off using the median, or sometimes even the mode to describe scores rather than using the mean itself. And one thing that you'll always notice is that they always go in order: mean, median, and mode. Okay, all right. So either the mean will be the smallest, and then the median, and then the mode, which the median and mode sometimes they're the same, and that's okay. Or the mean would be the largest, and then the median, and then the mode. But the median is always going to be either the same value as, or in the middle, though, between the median, or the mean, and the mode. So just a way to check yourself when you're calculating them. So, all right.